Hi.
Welcome back all of you. My name is Nitish Katiyar. I am here to give you a second tutorial on console multiphysics. In this tutorial I will show you how you can access console console multiphysics application library. So for this you have to click on file, and from here you can see what products your license have, and from here you can see this license and use product. I am not opening this because this license is provided by institute. So you can see from here how many products uh, purchased by your institute, and you can access only those products. So to open application library we have to click on this, and from here we can open any model, and for example I am going to open phase change, and we have to click on this, and this is the problem description about model, and from here we can open its PDF format, and for this we have to click on this, and this will open the file, and from here we can see the what is the problem, and uh, what are the material properties and what is the physics behind this model, and how they have created the geometry, and how they have defined the material properties, variables, and then how they applied physics and boundary conditions, and then study, and then post processing to for plotting the results. So this is the step by step documentation of the model. So by following this we can create this model. This is very helpful. So this is the PDF format, and uh, from here we can open .mps file. So for this we have to click on this, and this will open the model, and this will going to take time because from yeah. So this is the model. Okay, and now we can see all the step from here. These are the some parameters, because phase change require transition temperature, transition interval, latent heat of fusion, initial temperature of the, we can adjust this, of the rod, and this is the temperature of hot water, density of ice, density of water, and the ratio of densities. Okay, this is the problem related to melting of ice. Okay, and this is the step function they have defined. From here we can define it from here: analytic function, interpolation, piecewise, and from more functions we can define these Gaussian pulse. This is a frequently used in laser simulations, ramp, rectangle, and in defining pulse we can use this, and now this is the component, and we can see every step from here. This is the geometry, this is the one dimensional. Okay, and this is the material, ice and water, and then they have applied the physics, heat transfer in fluids. Okay, then this is the fluid node, and this is the phase change, and from here we can see all the steps. This is the equation behind it, and here theta 1 is the fraction of solid, theta 2 is the fraction of liquid, that is theta 1 is the fraction of solid ice, and this is the for water, this is the density of ice, and this is the density of water, and this is the uh, overall latent overall specific heat capacity at constant pressure, and this is the diffusivity. I think this will be diffusivity. This is the thermal conductivity, and this is the fraction. Theta 1 theta 2 is equal to 1, that means solid fraction and liquid fraction, that will make 1. Okay, these are the number of phase transitions. This is the sketch. Okay, and phase change of temperature between phase 1 and phase 2. This is the phase change temperature, this is the transition temperature, and this can be found out from literature. This is the latent heat from phase 1 to phase 2. That means when we apply heat to the solid ice, then this heat will be stored. Okay, so this is the latent heat of from phase 1 to phase 2. And phase 1 material is ice, and this is the thermal conductivity, density, and heat capacity at constant pressure, ratio of specific heat. And this is the properties of water, like thermal conductivity, density, and constant heat, pressure capacity, and ratio of specific heat. Okay, and this is the room temperature, and this is the thermal insulation. And here they have defined temperature, and this is the mess. Okay, and these are the some studies they have done, time dependent study. From here you can input start time and step time and stop time. Okay, and you can change from here also, and as per your requirement. And they have done one more study. This is a time dependent study, and one more study, this is a parametric sweep. They have input different transition temperatures. I think this will be the transition, yeah, transition interval. Okay, and then this this is the result, and this is the post processing. And we can see various plots from here. Okay, so this tutorial is related to how we can use, how we can open already inbuilt model that is provided by console multiphysics. So suppose you want to work on acoustics, then you can go into this application library, and then you can click on this acoustic module, and then you can open these already inbuilt models. And from here you can learn how to apply, how to create geometry, how to apply materials, how to define variables, and how to create mesh, how to define different studies, and how to do post processing. So same thing can be done for a battery design module, CFD module, and many more things can be done. So this is all for today, and I will come with next tutorial. Thank you for watching.